Hello and welcome. In this first part of our lesson, we are going to be discussing wave, and we are going to focus on solving past questions involving wave. We are going to be solving only past questions that contain calculations. The ones without calculations, we are going to skip them. So I've compiled some past questions, both WAEC and JAMB, involving wave, the ones with calculations. So I'm going to show you easy way to get them solved. In this lesson, we are going to look at the following subtopics under wave. These are the major calculations that you can come across in this topic, wave. So we look at wavelength, the wavelength of a wave. We get calculations or questions where we are asked to calculate wavelength of a wave. We'll solve them. Then velocity of a wave, how to solve it, frequency of a wave, period of a wave, we also look at velocity of sound under temperature variation, velocity under temperature variation, that is when we have different temperatures, how does it affect the velocity? We see calculations involving variation in temperature and how to solve it. Under temperature variation, then we also look at frequency of overtone. When you are asked to find the frequency of an overtone or the frequency of a certain position in an overtone, how do you calculate it? We'll get a past question involving this kind of calculation and we'll try to solve it. Then we also look at the frequency of a closed pipe, frequency of a closed pipe, we look at frequency of an open pipe, we also look at frequency under string length variation, frequency under string length variation. That is when we have different lengths of a string, like a guitar of different lengths, how do you compare the frequencies in the different lengths of the string? It has some calculations and we'll see how to get that solved. Then we also look at echo. How can we calculate the echo of a sound? These are the most popular or common calculations you can see on this topic, wave. The most common or popular calculations involving wave. They fall under these subtopics I just mentioned, and we're going to pick like one question and solve in each of them and see, so that you can understand how these things are solved. Now, for wavelength, I'm going to discuss wavelength, frequency, and speed together. For wavelength is represented with this symbol lambda. Frequency F, velocity V, time T. These are basic terms in wave. So let's discuss them together and solve a question that involves this. You can recall that when we discussed motion, we said that velocity is equal to distance over time. Velocity is equal to distance over time. In wave, distance is regarded as wavelength. The distance of a wave is a measure of its wavelength. So we replace D with wavelength. So in wave, instead of saying V is equal to D over T, we say V is equal to lambda over T. Lambda over T. Now, frequency is generally regarded as a reciprocal of time. A reciprocal means 1 over that thing. So frequency F is equal to 1 over T. Now, since frequency is equal to 1 over T, from this equation, it means that since 1 over T is equal to F, this equation is actually, or can be broken up into its components. Its component is, it is the same thing as lambda over 1 multiplied by 1 over T. If you multiply these two things, it will give you this. So in this case, we can now replace this 1 over T with F, since F is equal to 1 over T. And so we can now write that V is equal to F lambda. F lambda. So this is the equation connecting velocity, frequency, and the wavelength of a wave. Now let's solve one question on this. We have that a radio wave this is a past question, WAEC past question. A radio wave has a wavelength of 3 times 10 raised to power 8 meter per second. I'm not going to write down everything. I'll just be writing down the parameters. A radio wave has a wavelength of 3 times 10 raised to power 8 meter per second. So the velocity is, a radio wave has a velocity, not wavelength. A radio wave has a velocity of 3 times 10 raised to power 8 meter per second. So V is equal to this is our V. Now, if a radio station sends out a broadcast on a frequency 800 kilohertz, if a radio station sends out a broadcast on a frequency of 800 kilohertz, okay, we have frequency is equal to 800 kilohertz. Now we are asked to what is the wavelength of the broadcast. What is the wavelength? We are looking for the wavelength. Now we now recall that we have an equation connecting velocity, frequency, and wavelength, which is V is equal to F lambda. Now, before we solve, we must convert the frequency to the normal unit of frequency. The normal unit of frequency is hertz, not kilohertz. What we are given is kilohertz, 800 kilohertz. So we must convert this 800 kilohertz to hertz. Kilo means 1000. So we multiply the 800 by 1000 to get the equivalent amount of it in hertz. So it becomes 800 times 1000 hertz. Therefore, we can now say that our F is equal to 800 times 1000, which is equal to 800,000. We have converted the frequency from kilohertz to hertz. Now we put it in the formula to solve. So V, we know our V. Our V is 3 times 10 raised to power 8 is equal to, frequency is equal to 800,000. Now multiply by lambda. This is the one we are looking for. So lambda is equal to so when you solve this, whatever you get is the answer. So that is how to solve this kind of question. In your exam, they may ask you to find frequency instead of wavelength. In this our example, we solved for wavelength, but in your exam they can give you the wavelength and ask you to find the frequency, or give you the frequency and ask you to find the velocity. Anyone that asks you to solve, the most important thing is for you to remember the formula, which is V is equal to F times lambda. Once you remember the formula and you bring out your parameters and you do your unit conversion. If necessary, you can get the answer easily. Okay, that would be enough for that. Now we go to another one. We have this question: if a sonometer has a fundamental frequency of 450 Hz, a sonometer has a fundamental frequency of 450 Hz. The frequency of it is 450 Hz. Now, what is the frequency of the fifth overtone? Frequency of the fifth overtone. Now, fundamental frequency is represented with F0. Now, for overtone, frequency of overtone, this is how we get it. You can be asked to find the frequency of a certain position in an overtone. You should go and read up overtone. Note the difference between overtone and harmonics. I'm not going to talk about that. Just read up that one. I will focus on calculation. Now, for you to get the frequency of any position in an overtone, you use this formula. F of n position is equal to the fundamental frequency multiplied by n plus 1, where n is equal to the position, n plus 1. So if they ask you to find the frequency of the second overtone, then that means that n is equal to 2. If they ask you to find the frequency of the third overtone, that means that n is equal to 3. If they ask you to find the frequency of the fourth overtone, that means that n is equal to 4. So you now put n there and then put it in this formula. You now add 1 to n and multiply it by the fundamental frequency given to you. So in this case, we are asked to find the fifth frequency of the overtone. So what it means is that n is equal to 5. N is equal to 5, and then we are now going to say that our F5 is equal to F0 times n is equal to 5, that is 5 plus 1, which is equal to F0 times 6. Now we know our F0. Our F0 is the fundamental frequency given to us, which is 450, is equal to 450 times 6. So when you multiply this, whatever it gives you is the answer. That is how to solve questions involving frequency of overtone. It depends on the position they ask you to find, position of the frequency they ask you to find. Anyone they ask you to find, you use the formula, add 1 to the n and multiply it by the fundamental frequency. Then you get your answer. It is very, very simple. Now let's move to another question. Here is another question. We have this question that in a resonance tube experiment, if the fundamental frequency of the sound vibrating if the fundamental frequency of the sound vibrating a column is 280 Hz, the frequency is 280 Hz, then let's say the frequency of the third overtone is what? What is the frequency of the third overtone? This is the fundamental frequency. F3 is now going to be 280 multiplied by, since n is equal to 3, so we now say n plus 1, which is 3 plus 1 is equal to 4. So when we multiply this, whatever it gives us is the answer. Now let's look at another form of question in wave. We have this question. This one says, what is the speed of sound at 100 degrees Celsius? What is the speed of sound at 100 degrees Celsius if the velocity of sound at 0 degrees Celsius is 340 meters per second? Now this is a question from temperature variation, velocity under temperature variation. So we have different temperature here. Now we have the first velocity, we don't know it, and at this velocity the temperature is equal to 100 degrees Celsius. So T1, let's call this one V1. V1, we don't know it. T1 is equal to 100 degrees Celsius. Now V2 is 340. Meters per second, while T2 is equal to 0 degrees Celsius. Now, for us to solve a equation that involves temperature variation, we use this formula. The formula is V1 over V2 is equal to root T1 over root T2. Root T1 over root T2. But before we solve this, we must make sure that the temperature is in the SI units. The SI units of temperature is Kelvin, not Celsius. So we convert the temperature given to us from Celsius to Kelvin. If we do that, 100 degrees Celsius is equal to convert to Kelvin, we add 273 to the temperature given to us in Celsius. So 100 is going to be 100 plus 273. That will give us 373 Kelvin. That is for the 100 degrees Celsius. Y for 0 is going to be 0 plus 273, and that will give us 273. That will give us 273. So what it means is that our T1 is equal to 373, while our T2 is equal to 273. So we now put it in the formula. If we put it there, we now have that V1, which is the one we don't know, over V2, which is 340, is equal to root T1 is 373 over root T2 is equal to 273, 273. Now, what it means is that V1 multiplied by root 273 is equal to 340 multiplied by root 373. Now, if we solve, we now have that V1 is equal to, go back, V1 is equal to 340 multiplied by 373 root 373 then over root 273. I don't have a calculator with me. If you multiply this out, if you simplify this, whatever it gives you is the answer. So this is how to solve a question that involves temperature variation. Okay, now let's move to another form of question you can encounter in this topic. We have this question. If the fundamental frequency of a closed pipe is 256, if the fundamental frequency of a closed pipe is 256, the frequency is 256, you must notice the subtopic where the question is coming from. They say closed pipe, so we are solving question that is related to closed pipe. The fundamental frequency is 256. Now, they say, and velocity of sound is 340. If the velocity of sound is 340, so we have V is equal to 340. We are asked to calculate the length of the pipe. We have a closed pipe. The frequency is 256 and the wavelength is 340, and we are asked to calculate the length of the pipe. This is the formula to use. For a closed pipe, frequency is equal to velocity over 4L. This comes from, remember that frequency, we say that V is equal to F lambda, our initial formula. V is equal to F times wavelength. Now, if you make F the subject, it means that F is equal to, it gives us that F is equal to V over lambda. In a closed pipe, lambda or wavelength is equal to 4L. So when we replace the wavelength by 4L, we now have that in a closed pipe, frequency is now equal to V over 4L. That is how we got this formula, that frequency is equal to 4L in a closed pipe. That is the formula you are going to use to solve this question. Now, how do we solve it? We now put everything that is given to us. We have our frequency. We have our frequency as 256. So we say 256 is equal to, what is the wavelength? What is the speed? The speed is equal to 340 over 4L, where L is the length of the pipe. So once we get the L, that solves the question. So that gives us that 4L times by 256 is equal to 340. Now that gives us that 4L is equal to 340 divided by 256. Now L is equal to 340 divided by 256 multiplied by 4. When we simplify this, whatever it gives us is the value of L. Whatever it gives us is the length of the pipe. So that is how to calculate the length of a pipe the length of a closed pipe if we are given the frequency and the speed or velocity. Now for an open pipe, we have a closed pipe and we have an open pipe. A closed pipe is a pipe that one end of it is closed while the other end is open. Why an open pipe is a pipe that both ends of it are open, like a flute. A flute where both ends are opened is an open pipe. There's also a certain type of flute where we close one end of it. That one is a closed pipe. But if both ends of it are open, then we say that it is an open pipe. And in each of them, we have different formulas for calculating the length of the pipe. For open pipe, depending on the frequency and the speed of the sound produced, we can calculate the length of the pipe. For open pipe, it is given by this formula. F is equal to V over 2L. So just remember it that for closed pipe, we have F is equal to V over 4L, but for open pipe, instead of 4, we have 2L. For that question we solved before, where we have F is equal to 256 and V is equal to 340. So what we are going to do is that we now have 340 over 2L, and then we solve the same way we solved for closed pipe, and whatever we get is the length of the open pipe. Is the length of the open pipe. If we use 4 to solve, we are solving for closed pipe, but if we use 2L, we are solving for open pipe. Okay, so that is it for closed and open pipe. Now let's go to another question. Let's solve this question. A man standing 300 meters away. This question says a man standing 300 meters away. So distance x is equal to 300 meters away. 300 meters away from the wall, 300 meters away from the wall, sounds a whistle. A man standing 300 away sounds a whistle. The echo from the wall reaches him 1.8 seconds later. T 1.8 seconds. A man standing 300 meters away from the wall sounds a whistle. The echo from the whistle reaches him 1.8 seconds later. Now calculate the velocity of sound in air. This question is from echo. This is an echo question, and when we want to solve a question that is related to echo, the formula is this: V, velocity, of course we said velocity is equal to distance over time. In echo, you send a sound, then the sound travel and now come back to you. So it means that the sound is making two journey. The journey to get to where it is going and then coming back. So instead of having one distance, it multiplies it by 2. So if x is equal to 300, then the total distance it travels is going to be 300 times 2. So the formula for echo sound is V is equal to 2x over t. So whatever distance that they give you, you multiply it by 2 and divide by time. So this is just from the normal V is equal to d over t. Now because the distance is multiplied by 2, we have 2x then over t. So in this case, we now have that the velocity is equal to 2 times 300 over time is equal to 1.8. Now when we divide this, whatever it gives us is the velocity of the sound. That is the velocity of the sound in air for this echo sound. Alright, so that brings us to the end of wave. We have solved different questions involving wave. You try to remember the formulas for each of the subtopics under this wave, and you note the steps taken to solve them. If you follow this lesson, you won't have any issue with a question, any calculation involving wave. Thank you.